What's up everyone, welcome back. Patrick here, and moving on to another trig limit. We got the limit as x approaches 0 of tan mx over sine nx, where m and n are just some kind of real number. Just think of them as constants, and the variable we're working with is the x. Like I did in the previous examples, going to be using this toolbox here. We've talked about these results. We've derived some of these results in the previous examples. And so we're going to be using them to help us in the process of this. So if you didn't watch the previous examples on the site, make sure you do before watching this one, because lots of stuff is carrying over. And I'm going to be going through, if I run into something like this, I'm going to be going through it quicker than I did before. So make sure you watch the previous examples, make sure you fully understand what's going on before watching this one. So we got the limit as x approaches 0 of tan mx over sine nx. And the first thing I'm going to do is I'm actually going to split these up here. So I'm going to rewrite this as tan mx multiplied, actually let's put it in a square bracket, multiplied by 1 over sine nx. Like that. Now this tan mx I'm going to rewrite as sine mx over cos mx. So you remember, if you have sine x over cos x, or yeah, that's just equal to tan x, right? Sorry, I should have wrote it the other way. If you have tan x, that's just equal to sine x over cos x. But it doesn't necessarily have to be just an x. Just in general, tan of any expression is equal to sine of that same expression over cos of that same expression. So notice this mx, it's an expression, so we can rewrite this as the limit as x approaches 0 of sine mx over cos mx. Then I'm still multiplying by this 1 over sine nx. And now what I'm going to do here is I'm actually going to mix these up a bit. So I'm going to interchange the cos mx and the sine nx. I'm going to bring the sine nx over here. I'm going to bring the cos mx over here. We can do that because we're multiplying fractions here. And notice when I do bring the sine nx over here, we're going to end up in this format. So doing that, we'll have sine mx over sine nx. And then over here, we'll end up with 1 over cos mx, like that. And now notice that we have the limit as x approaches 0 of two functions that are multiplying by each other. So we can actually split up this limit. We can distribute it, if you will. So we'll have the limit as x approaches 0 of sine mx over sine nx times the limit as x approaches 0 of 1 over cos mx. Like that, right? Using limit laws. Multiplying, so we could split it up into two limits like that. And now notice this is this result that we got in a previous example. So I went over the work in that example. It was m over n. And then notice here, because this is a cos, we can actually do a direct substitution. Because notice here we'll end up with 1 over cos of 0. If we plug in 0 for this x, m times 0 is just 0, so we'd end up with 0 here. And what's cos of 0? Cos of 0 is just 1. So we'd end up with m over n times 1 over 1, which is just 1. M over n times 1 is just m over n. And so this actually ends up being this. Now, if we did a video on this result, did a bunch of work, so I'm assuming you've watched that video. I wrote out the result here. If you want to show that work a little bit quicker, right, if you don't want to go through all the steps in that video, what you can do, make sure you watch that video though, make sure you understand what's going on, because you may have a hard time understanding what I'm about to do here. If you got sine mx times sine nx, like this, or over sine nx, what you can do, in the video we split this up, but what you can do is just multiply it by mx over mx, and then multiply it by nx over nx. So it's like we're multiplying it by 1, multiplying it by 1 again. Right? So this expression is pretty much staying the same. And now what we can do is we can sort of mix and match these. So we'll have the limit as x approaches 0. This mx I'm going to put under this sine mx, like that. Okay, so that and that got taken care of. This nx I'm going to put over this sine nx. So then we'll have nx over sine nx, like that. So that and that got taken care of. And then this mx I'm going to put over this nx, like that. So that and that got taken care of. I just mix and match these. Notice that the x's here cancel out. So that's just m over n. We could distribute the limit, right? We could create 3 different limits here. We'll have the limit as x approaches 0 of sine mx over mx times the limit as x approaches 0 of nx over sine nx. And then the limit as x approaches 0 of m over n, that's just a constant. So we know that that's just going to equal m over n. So we could just keep that as m over n. Okay, and then over here you just follow the exact same steps that we did before. We could do a change of variable here, so we could let theta equal mx, and as x approaches 0, if theta is equal to mx, that means theta is going to approach 0. So we'll have the limit as theta approaches 0 of sine theta over theta, like that. For nx, let's bring in another variable, maybe a capital A we used before. You can maybe use another Greek letter to keep things consistently. I'm just going to use an A. So we'll have the limit as A approaches 0 of A over sine A. Then we still have this m over n. Now remember, this here we can rewrite as limit as A approaches 0 of 1 over, we can just flip that fraction like that. And then we could distribute this limit to here. It would just end up being 1. And then distribute this limit here, which would be limit as A approaches 0 of sine A over A, which is in this format. And notice that this is in that format as well. Okay, so this ends up being 1. This ends up being 1. And then we got that m over n. Right? And so, yeah, this whole thing here, if you want to do it quicker than the previous example, this is how you could do it. You could just multiply that mx over mx times nx over nx all at once, and then just do all of that. Because in the previous example, kind of went over it a little bit more slowly so you understand more what's going on. So anyway, whichever way you do it, going back to this example, this ends up being m over n. This ends up being 1 over 1. So the answer is m over n. So whenever you get something in this format, answer is just m over n. So if we had the limit as x approaches 0 of, let's say, tan 3x over sine 7x, we know the answer to that would be 3 over 7. So if it's in this format, no matter what constant is here, you can just follow this work, everything that I did, and you'll end up getting that result m over